and welcome to another edition of this class. Today we are treating linear regression. Linear regression is actually a type of supervised learning algorithm. So let's get to it. So linear regression with Python, this is mostly just code reference. Please, don't worry. Your neighbor, your neighbor is a real estate agent and wants some help predicting the house price of regions in the USA. It would be great if you could somehow create a model for her to allow her to put in a few features of a house and return back the estimate of what the house would sell for. She has asked you if you could help out with your newfound knowledge in data science. You said yes and decide that linear regression might be a good path to solve the problem. Your neighbor then gives you some information about a bunch of houses in the region of the United States. It is all in data set USA housing of CSV. Data contains average area income, that's average income of residents in the city house is located in, average house age, that's the age of house in the city, then average number of rooms, then average number of bedrooms, then area population, that's population of city or location, price, then address. You know what you want to predict is price. So let's move on from there. Why is my cursor not moving? Oh, sorry. I'm supposed to clear my kernel actually. So let me clear my kernel. Clear outputs. Yep. Why my cursor is not moving this thing? So basically we are importing our libraries. So here's are the libraries we are using. Then we are using pandas, we are using numpy, we are using matplotlib for plotting, then seaborn. So here we are importing our data sets. Sorry, made a mistake there. So I've imported our data set. I want to see the head of our data set, that is the first 5 rows of our data set. So moving on from there, we are checking the info of our data set, that's going to give us the number of missing data, the type of data set we have. So we have area income to be float, that's continuous data, then area housing age, that's continuous, that's area number of rooms, number of bedrooms, that's continuous too, that's area population, then price, then area address. Area address is object and we can't really use object for our machine learning, so we have to do something about that on the long run. Then we want to describe our data, that is we want to find the count, the mean, the median, the standard deviation of all the continuous data sets. So here's the count, the mean, you can see the mean, we have the standard deviation, we have the minimum, we have the 25th percentile, the 50th percentile, the 70th percentile, and the max. If you don't understand any of these things, probably should check our previous classes. I guess I've explained them. So here, then the columns, that's the columns that we have in our data set. We have the average area income, average area house age, average number of rooms, average area number of bedrooms, average population, area population, then price, then address. Then we have the historical data analysis. That's this. We want to quickly do some data analysis. So we want to do pair plot visualization. That's we want to plot all the columns against each other. Then we have the scatter plot and the histogram. I don't know why it's taking this long to plot. Wow, I never knew it's going to take this long on my new system. But then let's wait for it to finish plotting. It's almost done actually. So here is the plot. So the main diagonal will be histograms. Then we have our average area income against average area age, average area number of rooms, average area number of bedrooms. So you can see the plots there. But then I don't like the way it's plotted here, that we have to scroll around. I love it when it's just one chunk. Then we have distribution plots for the price. So we want to see the distribution of the price now. So distribution of the price. So distribution of the price is distribution of the price. Then the correlation plot, correlation of each of these things against each other. You can see the correlation. That's we can see the one with the highest correlation here with the housing price is average area income, which is 0.6. Of course, the income of the area will determine the price of the houses in that area. So that's actually quite nice. Then we have our heat map of our correlations. So you can see what we have here. You can see the orange that we have here. Then we can see this deep this one are very close to black because they are very close to 0. So you can see all of them here. Then you can see this, that's very close to 0.62. So if you check, what's that, area number of rooms and area number of bedrooms, that's area number of rooms and area number of bedrooms. Of course, area number of rooms will be close to area number of bedrooms, obviously, because rooms is part of bedrooms. You get it. That sitting room is part of bedrooms too. I mean, it's part of rooms too. That's why. So we are separating our data into the what's it called now? The dependent variable and independent variable. The dependent variable is the price that we want to predict. The independent variable are the ones that are predicting the price. So we separated them here. So moving on from there, when we are doing our training test, that's to split our data. So we have our training set and our test set. So we can have some that the machine learning algorithm will learn on, and some that it will predict on to test it actually if it's actually good or not. So here is the train test split now. So we are imported that library, then we are splitting our data. So we are using 40% of our data for our test size, which is actually a bit on the big side. But normally I use 80% for training and 20% for testing, or 70% for training, 30% for testing. But here I'm using 40%. I must have a reason for doing that. Then here we are importing our linear regression model. That's from our sklearn library. So we can see from sklearn.linear model, import linear regression. Then we are assigning our linear regression function to LM. Then we are fitting it to our training set. Then after fitting it, we printed our intercept. Our intercept is minus this, that is when every of our data point is 0. That is the value of the house. But then there is no real need for that. Then we are printing out our coefficients. So we have our coefficients here. So when everything is 0, the average area income is average area income 21.52. That's 21.52 times the average area income. That's the coefficient. If the average area income is 1, so it will be 21.52 plus this to give us the price of the house. Then we have all these other ones. Then average area age. So the age increases the price of the house by this particular number. Average area income increases the price of the house by this particular number. Then average area number of rooms increases the price of the house by this particular number. The average area number of bedrooms increases the price of the house by this particular number. The average area population increases the price of the house by this particular number. So having done that, so you can see I've explained everything I said there. I've explained it here. So that's that. Then we are predicting our test set now. So we are predicting our test set. We've made the predictions. Then we are comparing our test set to the predicted to the actual value. You can see it actually goes on almost a straight line, meaning our accuracy is actually on a very good side. Then here we are doing a scatter plot of our test against test. You can see our test against test is actually a straight line. Then our test against predicted is actually a straight, not totally straight line. So you can see that. Then we are checking our residual histogram. So we are doing that's residual histogram is just basically checking subtracting the value, the predicted value from the actual value. Then we are doing the histogram. You can see what we have here, that our histogram is actually almost normal, except for the fact that it's actually like straight on the peak, but then it's still normal. So we fulfill the assumptions of linear regression. Then we can do some regression evaluation matrix. For example, we have the mean absolute error, which is this. We have the mean squared error, which is this. We have the root mean squared error, which is this. So these are the formulas to calculate all those ones. So in case you need a more explanation on this, I will recommend a book. I'll probably paste the URL to the book on under this video, so that you can easily download the book. The book is actually free online, but the book treats the problem with using R. But then you can always understand the theory. Then you come and watch the video to understand the practical aspect of things. So we are importing our matrix from sklearn. Then we are checking for our mean absolute error is 8288. Mean squared error is like over millions. Then we have our mean root mean squared error to be 102,278. So that's that. So we've been able to make a prediction for our neighbor that needs a model for his housing whatever. So you can have this and give it to your neighbor and tell oh, this actually is going to give you a very good ballpark price of the houses, whichever house you give to it as per. You can see how it's working here compared to the actual thing. So it's going to give you a ballpark value of the house. So that brings us to the end of what's it called now, regression model. I mean, that's regression for machine learning. That's linear regression actually. So we'll treat other models in subsequent videos. Thank you and God bless.